Okay, so 8.1, nervous system concept map. As I said, I made a little mistake and forgot to put somatic nervous system on there. Well, I told you to do that first thing. All right, well, first of all, where does the information processing happen? Any ideas? The brain. Now, brain is not a choice here. Central nervous system. So that's what this top part represents. CNS, which is actually the brain and spinal cord, right? Okay, so we've got the CNS. Now, all these arrows out here, these are all representing pathways going in and out. Okay, so this is all the stuff outside the central nervous system. What do we call that? Peripheral nervous system, or PNS. Okay, so make sure you're getting all these corrections made. All right. So that's what this box represents here, is supposed to be the peripheral nervous system is all this. Okay. Now, these first two boxes we have here are representing the pathway in and the pathway out. And those two are going to be afferent and efferent. So the pathway going in here is going to be the afferent pathway, okay, or afferent division according to the possible answer there. So we have central nervous system done, peripheral nervous system, we've got afferent division. And then the pathway going out is going to be the efferent division. So we can cross that out. Okay, so talking about the pathway coming in. All right, the first thing we need to do in order to get information and bring it in towards the central nervous system is we have to have something that can tell us what's going on. Something that can receive information. Receiving receptors. That's what this box down here represents. And we can have some different types of receptors, which we'll talk more about. So receptors, that would be this. Gone. All right. Now, in terms of where the messages are coming from and where the messages are going to, we're still going to be thinking about the voluntary and involuntary, which we talked about in the notes about somatic and autonomic. But that's not necessarily what we use for the receptors. We'll still use somatic, so we can have somatic sensory receptors. Okay, so that's one of those options. And so that is this. On. All right. And another thing to think about with automatic or autonomic, we think a lot about digestive system, those internal organs of the abdomen, which another way to refer to those is viscera. So our other type of receptor that can come from some of those organs that we don't really have our voluntary control over is one way to think about it. We call that visceral sensory receptors. Okay? So that takes care of this. All right. Yeah. It could, I guess those two could be interchangeable. Yep. You weren't talking about that one? No, because this is part of the pathway out. Okay. So what we send the pathway out. All right. So we have the efferent division, and like I said, just like the pathway in, we have messages coming from things that we do have control over, voluntary, and things that we don't have control over, visceral. Same thing going out. All right. We're sending out messages towards things that we do have control over, and we're also sending out messages to parts of our body, to things in our body that we can't just think about and control, which is what I refer to as automatic or autonomic, okay? So this first one, what we're going to have is this is the one I forgot to put, but this is going to be the somatic nervous system. And we can't flip-flop these either. I'll show you why. This just leads down to one box here, and it's because the somatic nervous system is really us just sending out messages to our muscles, all right, things that we can control to control movement. So the skeletal muscles, all right, so skeletal muscle, done. Somatic nervous system, done. Now this other more complicated pathway of the efferent division of the nervous system, this is going to be our automatic, what we don't control consciously. This is going to be what's called as autonomic nervous system. And this is really cool the way this works. I mean, it's a lot of things that we don't even realize. If you ever get embarrassed or if you get scared, the physiological effects of our body, what it does, kind of interesting. But there's a couple different divisions of that. We can have the sympathetic division or nervous system. What did I put? Sympathetic division. And we can have parasympathetic division. This is your fight or flight. You may have heard of that before. Or in this case, parasympathetic, the rest and digest or rest and repose, they call it. Those could be flip-flopped either way. There's not a particular order to those. All right. But so that is, so we took care of sympathetic division and we took care of parasympathetic division. We took care of autonomic nervous system. So the sympathetic division, parasympathetic division, going to the things that we don't just voluntarily control, and that's going to be our things like smooth muscle. It's going to be cardiac muscle in our heart. So sometimes we get scared or something. Maybe our heart starts to race. Playing video games. My wife always says video games, they're a waste of time. They're not good for you. And I said, do you know that it's actually proven that when you do things like PvP, your heart rate accelerates? That's good for your body. Heart rate accelerate, get the blood flowing. That's just an excuse, guys. It's not really good for you. All right. Well, another thing we don't have control over, glands. Yep, and so these things that we send messages out to, what they're called, part of the efferent division, the cause and effect idea I gave you the other day, we call these effectors. So effectors are just anything we send a message out to in the nervous system. So it could be skeletal muscle, could be smooth muscle, could be cardiac muscle, could be glands, any of those. Okay? So like I said, it's hard to visualize these pathways in the nervous system, but if you can get this down, if you can memorize this and practice this, then you'll have a really good understanding as we continue to go through the nervous system, how things within the nervous system are connected and how they work. All right?